August 2015, Common Core Geometry Regents Exam, Part 3. Answer all 3 questions in this part. Each correct answer will receive 4 credits. Clearly indicate the necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions in this part, a correct numerical answer with no work shown will only receive 1 credit. All answers should be written in pen except for graphs and drawings, which should be done in pencil. This is for a total of 12 points. So number 32. As shown in the diagram below, a ship is heading directly toward a lighthouse whose beacon is 125 feet above sea level. At the first sighting, point A, the angle of elevation from the ship to the light was 7 degrees. A short time later at point D, the angle of elevation was 16 degrees. To the nearest foot, determine and state how far the ship traveled from point A to point D. So there are 2 ways in which to solve this problem. I'm going to use the law of sines as a result. However, in the answer key given by Mr. Seibel on JMAP, he uses tangent function twice, and he solves for the same correct answer. It's just my preference. You can pick which you prefer. So we need to find to the nearest foot how far the ship traveled from point A to point D. I'm going to label that with an X. I'm going to start with these 2 supplementary angles here. I have a linear pair, ADB and BDC are linear pairs, and I get a difference of 164 for the other angle for D here. And now I have a triangle right here, and I know that the sum of all 3 angles in a triangle is equal to 180. And if I subtract the sum of 164 and 7 degrees from 180, I get a difference of 9 degrees, which is my angle measure for ABD. It's a little tight in there. There, I made it a little bit bigger. The next thing I'm going to do is use trigonometry in order to find the length of DB. So I have opposite over hypotenuse, sine of 16 is equal to opposite of 125 over, I'm going to label it as y. That's the variable I'm solving for. So y is equal to 125 divided by sine of 16, and we get a value of 453.4944. So using value, I'm going to set up my law of sines. So x over sine of 9 degrees is equal to 453.4944 over sine of 7 degrees. Cross multiply. And we get an approximation of 582 feet. So the ship traveled from point A to point D 582 feet. Number 33, triangle ABC has vertices with A, x, 3, B, -3, -1, and C, -1, -4. Determine and state a value of x that would make triangle ABC a right triangle. Justify why triangle ABC is a right triangle. Okay, so we need to figure out a value for x that would make triangle ABC a right triangle is first on the list. So I'm a very visual person, and the use of the set of axes below is optional, so I'm going to go ahead and graph at least B and C and kind of visualize where A might be. So -3, -1 is where B is. And C is at -1, -4. So I get a line here, And wherever the other line or point lands where y is 3, I'm just going to draw a line really quick where y is 3. So I need another line extending from B out here someplace that is perpendicular to this line right here. So as a result, I need to get a point that's going to create a negative or opposite reciprocal slope of BC. So let's find the slope of BC first. So that's the change of y. So negative 4 minus a negative 1 is negative 4 plus 1 divided by negative 1 plus 3, which is negative 3 over 2. That means the slope of BA has to equal 2/3 in order to have that perpendicularity, thus creating a right triangle. So I'm going to use that value, and y is equal to mx plus b, in order to find what the other value for x is. We know that b is negative 3, negative 1, and if I substitute that in with this slope, I'll be able to come up with an equation for a line and see which one lands where the y value is 3. It's a lot of a manipulation to do here. So I've now just found out that the y-intercept, the value for b is 1, and I'm now going to plug in this value of 3 in for y. So 3 is equal to, using the same slope as 2/3, x plus 1. I'm going to solve for x. So minus 1, 2 is equal to 2/3 x, cross multiply, I get 6 is equal to 2x, and divide by 2, x is equal to 3. So the coordinate is 3, 3. So the value of x is 3. So in order to prove that this is a right triangle, I'm going to prove that I have opposite reciprocal slopes. So if I proclaim that point A is 3, 3, I already found the slope of this line right here. I'm going to prove that the slope of BA is going to be the opposite reciprocal. So negative 1 minus 3 over negative 3 minus 3 is equal to negative 4 divided by negative 6, and that reduces to a positive 2/3. So there's my opposite reciprocal slopes. Okay, so triangle ABC is a right triangle because the slope of perpendicular lines are negative reciprocal slopes. Number 34, in the diagram below, AC is congruent to DF, and points AC, D, and F are collinear on line L. Let triangle D', E', F' be the image of triangle DEF after translation along L such that point D is mapped onto point A. Determine and state the location of F' and explain your answer. Okay, well, F' would map onto C because if translations preserve distance, which they do, and point D is mapped onto point A, then we can conclude that point F maps onto point C. Let triangle D double prime, E double prime, F double prime be the image of triangle D prime, E prime, F prime after reflection across line L. Suppose that E double prime is located at B. Is triangle DEF congruent to triangle ABC? Explain your answer. Yes, triangle DEF is in fact congruent to triangle ABC because AC is congruent to DF and the points are collinear on line L. A reflection preserves distance.